Look at the world around you. We often mistake the daily weather for the climate, assuming that the rain, the wind, and the warmth we feel are local, chaotic events. But this stability is an illusion. It is merely the byproduct of a colossal engine hidden thousands of meters beneath the waves. A slow, cinematic transition from a stormy surface down into the silent, heavy darkness of the deep ocean. The true architect of our civilization's comfort lies far beyond the reach of the sun. Scientists call this system the Atlantic Meridional Overturning Circulation, or the Great Conveyor Belt. It is the heartbeat of the Earth, a mechanism so vast it redistributes heat across the entire globe. But the data suggests this heartbeat is slowing down. To understand the future of our atmosphere, we must stop looking up and start looking down. Now, let's dive into the data and uncover the reality hidden in the deep. The ocean is not a single entity. It is a stratified machine, divided strictly by the laws of physics. When we gaze at the horizon, observing the crash of waves or the drift of the Gulf Stream, frankly, we are merely watching the skin of the ocean. These surface currents are swift, chaotic, and driven primarily by the friction of the wind. They react to storms, seasonal shifts, and the rotation of the Earth in real time. But they represent only the top 10% of the ocean's volume. A cross-section animation slicing the ocean, showing the frantic, fast-moving surface layer contrasting with to find the engine of the climate. We must ignore the wind and focus on weight. Beneath the sunlit zone lies the abyss, a realm where the water is no longer pushed by the atmosphere, but pulled by gravity. This is the domain of thermohaline circulation. The term comes from the Greek, thermos for heat, and halos for salt. These are the two levers that control the density of seawater. Cold water is dense. Salty water is dense. When you combine them, you create a fluid so heavy that it cannot remain at the surface. The Great Conveyor Belt is not a river pushed by the wind. It is a global avalanche of water pulled by its own crushing weight. This density-driven machinery operates on a timescale that dwarfs human history. While a surface wave might cross the Atlantic in weeks, a single drop of water entering the deep conveyor belt, it travels from the North Atlantic, snakes down the spine of the Americas, circles Antarctica, and resurfaces in the Indian or Pacific Oceans centuries later. It is a planetary heat pump. The surface leg of this system carries warm, tropical water toward the poles. As it travels north, it releases that heat into the atmosphere. This is why northern Europe is temperate, while lands at the same latitude in Canada are frozen. The ocean is literally breathing heat into the air, keeping our civilization in the Goldilocks zone. But for this heat to be released, the water must eventually sink. The entire global loop depends on a specific, violent event happening in a very specific place. The camera moves rapidly north, flying over the gray, choppy waters of the Greenland Sea, approaching the ice edge. The engine requires a chimney. If the warm water cannot cool down, become heavy, and plunge into the abyss, the conveyor belt stops. The surface weather we experience, the rains that feed our crops, point unnumbered, and the temperatures that define our seasons, is actually dictated by this vertical exchange. We are living on the roof of a boiler room, assuming the warmth is guaranteed. Unaware of the delicate pressure valves operating silently beneath our feet. We travel now to the engine room. Our journey takes us to the high latitudes of the North Atlantic, specifically the Greenland, Norwegian, and Labrador seas. Drone footage tracking low over turbulent, icy waves in the North Atlantic. The water looks heavy, almost viscous, with cold. To the unassisted eye, this is a hostile, chaotic expanse of gray waves and biting winds. But oceanographers see something else entirely here. They see the planet's lungs. This is one of the few places on Earth where the barrier between the surface and the abyss dissolves. To understand the thousand-year plunge, we must analyze the specific physics of this interaction. As the warm, salty water of the Gulf Stream arrives here from the tropics, it encounters the frigid Antarctic air masses. The temperature differential is extreme. The atmosphere acts like a massive heat sink, aggressively stripping thermal energy from the ocean. In the dead of winter, the ocean releases heat at a rate of hundreds of watts per square meter. The water is being flash-cooled. As water cools, its molecules crowd closer together. It shrinks. It becomes denser. But temperature is only half the equation. The second variable is salinity. In these high latitudes, evaporation is fierce, and when sea ice forms, a critical chemical separation occurs. When the ocean freezes, it does not freeze uniformly. The ice crystal lattice rejects the salt, forcing it out. This is the alchemical moment. The water just beneath the ice is now supercooled and supersaturated with salt. It has crossed a threshold of density that makes it heavier than anything below it. It can no longer float. It becomes gravitationally unstable. Suddenly, billions of tons of water begin to fall. A CGI schematic showing chimneys of vertical blue currents plummeting from the surface down through the water column. The ocean turns vertical. These are known as chimneys, columns of sinking water only a few kilometers wide but reaching all the way to the seafloor. This is the birth of the North Atlantic deep water. It is not a gentle settling. It is a collapse. And nowhere is this collapse more spectacular than at the Denmark Strait. Located between Greenland and Iceland, the Denmark Strait hosts the largest waterfall on Earth. But you will never see it, because it is entirely underwater. Here, The dense, cold water from the Nordic seas meets a ridge on the ocean floor. It pools behind this ridge until it overflows, plunging 11,500 feet into the abyss of the Atlantic. It dwarfs Angel Falls. It is 3 times the height of the tallest waterfall on land. The volume of water crashing down this submarine cliff is estimated at 123 million cubic feet per second. That is equivalent to 2,000 Niagara Falls flowing simultaneously. This massive injection of cold water drives the deep limb of the conveyor belt, pushing the old, stagnant water of the deep Atlantic South toward the equator. A side profile simulation of the underwater waterfall, showing the cold blue stream cascading down. This is not just moving water. It is measuring the pulse of the planet in Sverdrups.
The flow rate just spiked in the starboard conduit. I see that. Cross-reference with the pressure sensors immediately.
1 Sverdrup equals 1 million cubic meters of water per second. The total flow of all the world's rivers combined is about 1 Sverdrup. The Gulf Stream is about 30 Sverdrups. The overturning circulation involves the transport of roughly 15 to 20 Sverdrups of deep water. But this plunging water carries more than just momentum. Remember, this water was at the surface only days ago. It was in contact with the atmosphere. It is rich in dissolved oxygen. The deep ocean is suffocating. Or it would be, without this mechanism. Most of the deep ocean is sealed off from the air. Without ventilation, the oxygen would be consumed by microbial respiration, turning the depths into anoxic dead zones. The global conveyor belt acts as a planetary ventilator. This plunging water injects a fresh breath of oxygen into the deepest trenches of the world. When we send ROVs down to the abyssal plains and see varying forms of life, crustaceans, fish, microbes, we are witnessing organisms breathing oxygen that was absorbed by the ocean in the North Atlantic hundreds of years ago. The plunge connects the atmosphere to the abyss in a direct biological lifeline. Once the water hits the bottom, the journey changes pace. The violence of the waterfall ends, and the slow, grinding migration begins. This cold, dense water mass hugs the topography of the Atlantic floor, flowing south. It creeps over the abyssal plains, navigates around seamounts, and slides through deep fracture zones. Time-lapse map showing the slow blue arrows creeping south along the bottom of the Atlantic. This water has now exited the human timescale and entered geologic time. A water molecule that sinks in the Greenland Sea today may not see sunlight again until the year 3000. It acts as a massive storage locker for heat and carbon dioxide. By taking surface water and hiding it in the deep, the ocean effectively sequesters almost a third of the CO2 we emit, and 90% of the excess heat trapped by greenhouse gases. The abyss is our buffer. Without this thousand-year plunge, the surface of our planet would be drastically hotter. The conveyor belt buries the evidence of our changing climate deep in the dark, buying us time. It is a thermodynamic service provided for free by the physics of the planet. But it relies entirely on that delicate balance of salt and temperature in the North Atlantic. If the water stops sinking, the timeline breaks. And that brings us to the most unsettling realization of modern oceanography. The machinery is not indestructible. It requires the water to be heavy. But what happens if the Arctic warms? What happens if the glaciers melt and flood the North Atlantic with fresh, light water? Fresh water floats. If we dilute the salinity of the North Atlantic, we jam the gears of the engine. The water will no longer become dense enough to sink. The chimney will clog. The waterfall at the Denmark Strait will dry up. The lungs will stop breathing. This is not a theoretical model for the distant future. The geologic record shows us it has happened before. Let's dive into the data and uncover the reality hidden in the deep. Past is not silent. It speaks to us through ice cores and sediment layers, and the story it tells is one of abrupt, violent change. But the history of the conveyor belt reveals that the Earth's climate system is actually full of switches. And sometimes, someone flips the switch. The last time the engine stalled, the world changed in a decade. It was an event known as the Younger Dryas. Approximately 12,800 years ago, the Earth was emerging from the Ice Age. But suddenly, the northern hemisphere was plunged back into a deep freeze. For years, this was a mystery. Then, geologists found the culprit. A colossal glacial lake in North America, Lake Agassiz, had burst its ice dam. A volume of fresh water greater than all the Great Lakes combined rushed into the North Atlantic in a matter of months. This massive pulse of fresh, buoyant water capped the ocean like a lid. The salinity dropped. The density vanished. The deep water formation shut down almost instantly. The heat pump broke. Europe froze. Ecosystems collapsed, and the global climate system was thrown into chaos. For over 1,000 years.
Today, the dam is leaking again. We do not have a Lake Agassiz waiting to burst, but we have the Greenland ice sheet. As global temperatures rise,
Greenland is shedding billions of tons of fresh water into the very same chimney sites where the deep water forms. We are effectively diluting the fuel that powers the engine. And for the first time, our satellites are picking up the signal of a slowdown. It is known as the cold blob or the warming hole. If you look at a map of global warming, the entire planet is red, except for one stubbled patch of blue.
It's in the North Atlantic, south of Greenland. This spot is cooling because the supply of warm tropical water is failing. It is the only place on Earth that has cooled over the last century.
This is not a weather anomaly. It is the fingerprint of a stalling system. Current models suggest the AMOC, Atlantic Meridional Overturning Circulation, has weakened by about 15% since the mid-20th century. If it weakens further, the implications are not just colder winters in London. The consequences are global and systemic. The conveyor belt does not just move heat, it dictates the location of the world's rain belts. If the heat transport stops, the thermal equator shifts south. The monsoons that feed billions of people in West Africa and India could fail. The sea level on the east coast of the United States would rise sharply as the water that is normally pulled away by the Gulf Stream piles up against the shore. The ocean's ability to absorb carbon dioxide would plummet, accelerating global heating. Even as the North freezes. Blitzscreen showing a dried-up riverbed in the tropics and a storm-battered coastline in the North Atlantic. This is the definition of a tipping point. We are anatomizing this nightmare not to induce panic, but to understand the stakes. The ocean is not just a victim of climate change, it is the driver of it. The monster here is not a creature with teeth, but a physics threshold. We are currently walking the line of that threshold, testing the resilience of a system that has stabilized human civilization for 10,000 years. To understand our future, we must respect the mechanics of the deep. The circulation connects everything. The water vapor in the Amazon rainforest, the crop yields in the Midwest, and the storm tracks over Europe are all tethered to that silent, heavy plunge of water in the Greenland Sea. We are not separate from the abyss. Our atmosphere is merely the exhaust system of the ocean's engine,